Hello and welcome to this introduction lecture to microcontrollers presented by me, Adam Senzel. We will first be looking at some background before we head into the task around microcontrollers. So the microcontroller is a smaller but simpler computer, like the one you're probably using right now. It's a computer built for simpler purposes and systems, simpler, more uniform purposes. So they're programmable like a regular computer, by a regular computer, but they consist of a processor just like your laptop or your desktop, but much smaller and a bit slower, like with slower clock speeds. But this also means that they operate at a lower power, so it can be used in standalone devices and systems deployable by engineers. They're often used by embedded systems engineers and programmers to perform simple programmable tasks. Some of these tasks are examples such as monitoring a sensor, receiving data from the sensor, and maybe broadcasting it to a large system, or driving a motor where you control and drive a powerful motor. Otherwise, and other purposes such as turning on a light programmatically. Now for today's task, which is going to be blinking an LED using a microcontroller. So I'm going to be using Tinkercad to simulate all of these tasks. But first, we need an LED circuit. So the LED needs input voltage and to be grounded. It will also need a current limiting resistor to keep both itself and the microcontroller safe and operating within current limits. The resistor its value is calculated through Ohm's law based on the output voltage of the microcontroller, often called the board for short, and the turn-on voltage of the LED. Assuming the turn-on voltage of the LED is 2.2 volts for this red LED, and the board outputs 5 volts, then the resistor becomes 220 ohms, for a current of 10 milliamps. Next, I'll show you a little demonstration here, where I take this resistor in Tinkercad with a little breadboard, set the value to 220 ohms, as it goes there, and then I place both the resistor and the diode into the breadboard, connected together using the breadboard's backing wires. So there, they're both on the board. But now if we take a look at the LED, we can connect it to the resistor using the breadboard like that. Perfect. Now using Tinkercad, we can start working with the microcontroller. So we can add, you'll see in the video that I add an Arduino R3 from the components. And a microcontroller such as the R3 consists of output pins that can be programmed to perform different functions. So that's where kind of the connection comes together. So for the task of blinking the LED, we need a general purpose input output pin programmed for output. So GPIO there just stands for general purpose input output. And so we're going to use pin D13 on the Arduino R3 for this task. So these pins can be programmed with multiple different functions for different outputs, such as like communication methods and other communication protocols, and other kind of like they can even be programmed for inputs as well. But for this specific task, we're just going to be programming it as an output. So here the video will come up now. I've added the board into our little setup here. So now you'll see I select pin D13 and wire it through the resistor to limit the current that the LED gets, and wire the LED it needs to be grounded, as you saw from my previous slide. And so we wire that to the board's ground so that both the board and the external components are common grounded. Now we move on to the coding sector. So Tinkercad has a little block code system so that you can be able to work with simple logic like this. And so you'll see in the video just now. So what we're going to do is we need a little loop that runs always, so that we can just test for now that the output of turning this LED on and off works. So in order to see that we've wired up the circuit correctly, we need to program our wired pin to drive energy through it. So this way, we can programmatically control the circuit using logic coded onto the microcontroller. So here the video will come up now. So here you see I've opened up the code window, and I'm using an always loop or a forever loop, and I'm going to be just simply driving the LED high. It uses the D13 is the same pin as the internal LED, so both will go on and off. And here I drive it high, I have a delay, I drive it low again, and then have a delay once again. So now once we run this code, we'll see that the LED will just blink. And there we have it. So now the pin is being driven high and voltage is being sent into the circuit, and then delay is happening and the pin is being driven low again. Here for reference is the circuit diagram of the board and the circuit. So now that we know that we can drive an LED just on a timer on and off, we can go and move on to the next step, which is wiring the switch. So now we want to drive the LED with a switch instead. And so we need a switch circuit. So the switch is a value that's read into the board instead of just sending energy out of the board now. We're reading energy in instead. And so the circuit consists of the switch component wired through another pin on the board and connected to the ground. It's also connected, you'll see, to a high input, which is either 3.3, or high output of the board, which is either 3.3 or 5 volts, depending on the board you use. And that will then send the signal to the read-in pin. So here we have the board and the LED. I just shifted it over so it's a bit less cluttered. But there's our switch, and we connect to the breadboard. We then wire the one pin to the ground, so it's grounded. I'm using the black and red wires, so it's a bit easier to see. So I've grounded the one half of the pin, so that'll be the one half of the switch, which will be 0. I've set the middle, which is the red value, the reading value, to the pin that I want to program, which is D2. And then I'm setting the other side to the high value. So this I've set it to, I think, 5 volts, but 3.3 works as well. And now finally we can get to the main part, which is programming the switch in. So now back to the code again. We need to amend the code that we had to, instead of blink the LED periodically with a delay, we must now drive it on an input, which is the switch. So it needs to read the input pin of the switch and output that to the LED. Right, so now I've got a bit of a different code set up here. I've got still the forever block so that it's always checking for this, but I've created a variable for the storage of the switch's value, and I've set a block to set that variable's value when it changes. So whenever it changes, it stores that pin's value as a variable. Now we have an if-then block, which checks the value of the variable, and when it's 1, which means the switch is turned on, then we drive the LED high. So we send power to the LED pin. Otherwise, when it's 0, we set it down to low. So now you'll see when I run the simulation to test, I'm going to hit run, and then as we flick the switch, it'll send that one signal, which will drive the LED high. So there it's high, and I flick it, it goes low again. It goes high and goes low. So now it's reading the input signal on that digital pin, and that's defining the logic that outputs to the LED to tell it when to go high and when to go low. Okay, great. So in summary, that'll be the end of our lecture. We've looked at the basics of how a microcontroller works by looking at a practical task where we drove the output of a microcontroller to control an LED, and we use the input of a switch to manually change this LED's value, all through the processing of a microcontroller. Now we can see how they work. Thanks for listening.